All right, so today we're going to be talking about factoring polynomials by grouping. In your book, this is lesson 87. So what I'd like to do beforehand is do a little review, just regular factoring. When we look at two numbers as just a binomial, we're going to look to see what the greatest common factor is. And first we look at the constants and we say, well, 15 goes into 96 times. So, because 15 times 2 is 30, and 30 times, and 3 times 3 is 9. So we're going to have 6. 6 times 15 is going to be 90. But we also see that there's a k raised to the third in one of these terms and k raised to the fourth in the other term, which means that that's k times k times k and k times k times k times k here. So we're going to be able to draw out a 15 and k to the third. So that's what I've done right here. I've drawn out 15k to the third. And what's left over, if we were to divide them out, and sometimes when we're dividing them out, I usually tell you to look at it like this. And then 15 is k to the third. This is k to the fourth, sorry. What's going to be left over? Well, when we reduce this, this is going to be 1. That's going to be 6. There's going to be 1 left up at the top here, and this is going to be gone altogether. So 6k is what's left over. And because we were able to factor this completely out, what we need to understand is that 15k to the third over 15k to the third, what's that equal to? That's equal to 1. So you don't leave it blank, you don't take it out, you don't make it 0, you leave a 1 in there. So there's your review. Now let's go on to the actual lesson material. So factoring by grouping means that we take a look at this complex polynomial and we say, well, I do know some things. I know that I can factor out a 2 out of 2 and 4. And I know that I can factor out an x out of x squared and xy. So the greatest common factor for these two is positive 2x. Why did I write a positive 2x? You don't have to. But it's a nice placeholder here, because at some point, when you group these guys, you're going to need to know what the next operator is. And the next operator is going to be the sign for the greatest common factor. And the greatest common factor between these two, well, x and y, you can't draw anything out of that. But 7 goes into 14 twice, so 7 is the greatest common factor. And I put the positive here just to remind me that I'm going to draw that out. So when I draw out 2x out of these two that I've grouped together, what I get, I take the 2x out, and then I'm left with just an x. And then what I'm left out, what's left is 2y from 4xy. And, sometimes, like I said before, 4xy over 2x is the same thing as dividing it out. And so we know that this is going to be 1, and we know that we would reduce 4 halves into 2. So what's left over is 2y, and that's how we get the 2y right there. If you want to have that on your work, then feel free. So we're drawing out 7 from here, and when we divide 7 out of 7x, we're just left with x. When we divide 7 out of 14y, we're left with 2y. So we notice here that x plus 2y is the same as x plus 2y here. And so since this is multiplication and this is multiplication, we're going to factor out the x plus 2y from both of these terms now. And that's why there's only one of them here. And there are 2 of them up there. Then we consolidate these 2 and pull them into a binomial on their own. So 2x plus 7 becomes its own binomial, and x plus 2y becomes the other binomial. All right, let's try a little bit more challenging problem. I didn't double check to make sure. Oh, good. All fits in. Okay. So what we're going to do is we're going to be given, and both of these problems are actually on page 570 and 571 as your examples. So refer back to them if for some reason this is unclear. So we've got this complex polynomial. We've got 4 terms. You might be tempted to draw a 3 out of these two, but then that leaves you in a difficult position where you only have an A drawn out of these two. So they actually have them positioned nicely so that you can group them easily. But when you group these together, we can draw out positive 3A. And we can get 3a out of this term, and 3 goes into 8 6 times, so we get a 3a out of that as well. Here we only have a constant, so we're only going to be able to draw out a 5. And left again. Now, once we draw these common factors out, we're left with the 3a and the 5. But what's on the inside here is ab minus 6. And here it's 6 minus AB. So what I want you to think of is I could flip the signs on either of these, and it'll be correct. So I'm going to switch the signs on this set of terms. How do I switch the signs? I multiply by -1, and that'll change this. But I could have said I'm going to draw out a -5 at this point, and that would have taken care of it altogether. But you would have had to have seen that. So if you didn't, at this point you multiply all these terms by -1, and that makes this a -5, and in turn this becomes a -6 and an AB. Positive AB, which is the same as AB, positive AB, and -6. So we can then just switch terms as opposed to switching signs. So the same exercise, we could have left it like this for both of these binomials, but to be honest, just leave it as AB minus 6. Make it consistent so that we can consolidate them here. And then we're going to consolidate these outside greatest common factor terms as well. So this becomes 3a minus 5. 3a minus 5 is one term, a binomial term, and ab minus 6. So I just followed the sign of this first binomial. So let me know if you have any questions, and I hope this helps.